Dear friend, welcome to Hydrology Hub channel. In this lecture, I'll demonstrate how to carry out the 1D steady state and unsteady state modeling after extracting river cross section from a digital elevation model, means DEM, using HEC-RAS. So here, what you will need means a high resolution DEM for your study area, preferably in TIFF format, HEC-RAS 5.0 or later version. Then the GIS shapefiles for stream center line and bank lines if available. But don't worry, I'll show you how to digitize them too. And we need flood values, that means the inflow flood values and the flood hydrograph for 1D steady state and unsteady state modeling. So let's start. So first I will open the HEC-RAS. So here HEC-RAS 6.6 is there. I am opening the HEC-RAS 6.6. Just I clicked over there. So this window has opened. So first of all, I'll create a project. File, new project. So I'll give a name, 1D modeling. 1D model I have given. Okay. Now I will see whether my unit system is correct or not. So I'll go to the unit system and select the metric system. Okay. Now the next step is that I'll go to RAS mapper and then I'll set the projection system. So here I'll select the projection system. I kept the data DEM here in the document file. So I'll select the projection system, apply the projection system. Okay. Next I'll go to the terrain and add a new terrain or create a new terrain. Just click on the plus sign, select the DEM. So this DEM I have selected, and now I'll create the terrain. So the terrain is created. Close this one. Now to visualize where is my river, I can go to the map layer, just right click there, add a web imagery. From here I'll just add a Google map. So you can add various kinds of the map, like the Google satellite map, Google terrain you have, Google hybrid, so ArcGIS maps also. So I'll add here Google map just to see where is my river is there. So that is been added. So this is the river, you can just see over there. Okay, this river is going on. So this is the river is there. Okay, so now I'll just zoom this one, this river, and first of all I'll create the geometry. Now for creation of the geometry, I'll go to the geometry and just right click there and give the create new geometry and give a name, appropriate name to this new geometry. Right now I am leaving it as a new geometry. Okay, so this is created. Now what I'll do in this new geometry, I'll just again right click and go to the edit geometry. Now first of all I'll go to the river and I'll draw the center line of the river. Just see here, from the left mouse button just click over there and just using the left mouse button go on clicking, move the cursor using the mouse. From the left mouse button you can continuously click and you can draw the center line of the river. It's very easy. So basically what we are doing, we are trying to have the center line of the river. We will draw the bank line of the river, then we will extract the cross sections from the DEM so that we have the basic database for carrying out the modeling in HEC-RAS. So one way is, if you have the surveyed cross section, you can directly incorporate the surveyed cross section. So I have taken reach up to this point. Okay, now what I'll do, I'll draw the here, just click on here and just click the bank lines. Okay, here I'll put the bank lines. So left bank line and the right bank line I'll put. So you can see here, just and same way you can just have left mouse click, using the left mouse click and the cursor, you can go on. This way we are going. You just see this is the left bank line I am plotting. So this I have plotted left. Now, similarly I will plot the right bank line. So once you will do, you can do it very fast also. It's not much difficult. So basically you want to extract the cross sections. For that you need the bank line and the center line. So these bank lines are created. Now what we will do, we will go to the cross section. So here you can see cross section is there. So in the cross section we will just again draw the cross sections. Now here one has to remember that once we are plotting the cross section or marking the cross sections, always mark them from left to right. So the river is flowing like this. So that means your left side of the river is this one. So from left point to the right point, and it should be perpendicular. Try to have it's perpendicular to the center line. Okay. So just I am plotting the first cross section. Then similarly second cross section I have plotted. Third cross section I have plotted. Fourth cross section. Similarly you can just go on plotting the marking various cross section over there. You can have, sorry, this way we can just have so we have plotted all these cross sections. So now what we will do, we will save, stop this editing, and it says do you want to save? Yes. Now we will again go to the file and save this one and close. Now we will go to the geometry editor. Okay, from the main window. Now we will open the geometry what we saved here. Open this geometry. So now this geometry is there. You can have a full screen of this one. So now you can see that the dam and the geometry is available. And once you click on the cross section, so you will find that the cross sections are available. Various cross sections are available here. Okay. So these are the cross sections it is showing. Now here one thing you can just see. Here the n values, the Manning's roughness coefficient value is given as -999 in each and every cross section, because we have not yet defined the Manning's roughness values. And once you just see, you click here, it will simply show which cross section is this one. Okay, just one by one it is going, and it is showing all the cross section. So now next step is that we will give the Manning's roughness values. For that we will go to the table Manning's n values and select all these and give the Mannix reference values. So suppose it is 0.025. So now for all the cross section we have given the Mannix roughness values. So here now if you will see, it is coming as 0.025. You can just see here. Okay. Now close this one. You can save this geometry data. Okay. Now again close this one. So now your geometry is ready. Now we will go for the 1D steady state and unsteady state modeling. Close this one. So here we will go for the 1D and steady state modeling. Just click here. So you can have steady state for different discharges also. So suppose I want to see for different discharges, like for different 3 kinds of the discharges, 3 profile I want. So one for 500 meter cubic meter per second, 800 and 2000. Okay, yes, I am having this one. Apply data, then give the reach boundary conditions. So here we will provide the normal depth. So that is the slope of the river. So slope of the river is 0.0001 is there. Just apply. Okay. Close this one. Now you can run the model over there. Okay. Compute. You can give the plan name also here. So it is created. Close this one. Now we will open the RAS mapper. And just a minute. Again I will give some plan name here. Plan 01 and then compute. Close this one. Open the RAS mapper. Now in the results you can see your plan 01 has come up, and here you can just see what is the depth of the water. Okay, it is showing the velocity also. You can see the velocity, you can see the water surface elevation also. So all these things are, you can see, and these are for the profile 1. Now you can add other profiles also. Just go over there, in the right click in the plan 1, create new result map layer. Here just go to the water surface elevation. You can select other profiles also, add profile 3. Similarly for the velocity you can add other profiles. Similarly for your depth you can add profile 2 and profile 3. Close this one. So now you can see all the profiles are available over there. Okay, so here for the different cases, different floods cases, you can just see how much flood water is there. So suppose here your water surface elevation profile 1 is there. When the flood is very less, you have put it only 500 cumac, and once it is 2000 you are putting, so you can just see it's PF3, so it has increased. You can see the difference between two. So you can compare if the flood is more, so how the much flood water will be there in the river. Okay, if more flood water is coming into the river, okay, so what will the condition. Similarly that you can check the depth also, what will the impact on the depth for different conditions. Okay, so you can just check over there, right, and just see how much will be the depth of the water. Okay, so this is how you can carry out the 1D steady state modeling. You can also see the results here in this one. Go to here, and each and every cross section you can just see how much water is there. Okay, you can just check, go and checking. Okay, you can just click here. So this way you can just check. Okay, you can explore more results over there. Okay, similarly you can see the water surface profile also. Okay, how the profile is there, and you can select all the profiles, compare the results, how the profiles are there, so you can compare the results. So this way you can explore the results. Okay, now in the same data set I'll do the 1D unsteady state flow modeling. Okay, so for that what you do, you have to go to the unsteady state flow here. Here in this case, first on the upstream cross section, here I have to provide the flow hydrograph. Right now I don't have any flow hydrograph. I'll just take a I'll just assume an hydrograph over there, and hypothetical hydrograph I will take. So just I'll give the fixed start time from here. Let's suppose it's 1st September and time is 0 hours, and then initially it is 0, and at 10 hours it is, suppose maximum it is 2000 cubic discharge is there. Then at around 2nd September I'll consider at around 16 hours it is again 0. This way I am making the hydrograph, and I'll just fill in between values using the interpolate missing values. Okay, and here you can see, here I'll provide the slope of the river 0.0001, and I'll plot the data. You can just see I can plot the data. So this is the hydrograph I have, just hypothetical hydrograph I have given to the model. Okay, so this hydrograph I have provided. So it starts on 1st September 2008 at 00 hours, and it ends on 2nd September 2008 16 hours 0 at 14 hours or 16 hours, sorry. So this you have to remember, because during the simulation you have to provide this values. Okay, this time. Now one thing is over, we'll have this one over there, just click OK. Now again here in the downstream point you have to give the downstream boundary condition. So here again I will give the normal depth as 0.0001, that's the slope of the river we will provide. Okay, so just close this one. So now you have provided all the data. Go to the unsteady state flow modeling. Okay, give the start date, that is the 1st September, time is 0000 hours, end date is 2nd September, time is 16 hours. Here we will give these as 1 minute for the computation interval, hydrograph output 1 hour, mapping output interval 1 hour, and the detailed output as 1 hour. We'll go to the options. We'll just click on the stage and flow output locations. So what are the location, at what location you want the stage, all the results. So I'll select all these locations, means all cross section I'll select. I'll click here and say OK, and then I'll just click on these radio buttons and compute. So now it's simulating, so you have to wait for a few minutes. So right now our area is very small, it will quickly work, but if a large area is there, it will take a lot of time. So it says the complete process. Close this one, close this one. So here you can see the results again. So now in this case also you can see the results, how the flood water is there in the river at different cross sections. Okay, you can see the hydrograph also. Okay, at different location how the hydrograph is there. Okay, you can just see hydrograph condition. Okay, close this one also. Now I'll go to the RAS mapper. Okay, so now this is for the unsteady state flow. Okay, so yeah, now you can just see how the things are coming over there. So it shows the results, depth, it shows the velocity, it shows the water surface elevation. Okay, and you can just have the, because this is the unsteady state flow, you can just have the animation of this one also. I'm just reducing the animation speed. Okay, from here, and then I'll just have this. So how you can just see here. Similarly, I'll show this animation for the depth also. So this way you can just see all your animations and everything, how the flood water is moving into the river. Okay, so this way you can just animate all those things. So this is all about the 1D steady state and unsteady state flow modeling using the HEC-RAS. So here we have extracted the cross section from the dam. So if you have liked this video, please subscribe it, like it, and press on the bell icon. Thank you very much.